Hi everybody, this is Miss McClellan here to go over IM2 Notes 2.2.2 with you. How can I maintain the shape for similarity? Today we will focus on a relationship between the lengths and of sides of dilations by enlarging and reducing polygons and looking for patterns. Then we're going to learn what it means for two polygons to be similar. Now we have two learning goals. Number one, I will be able to, given a pair of similar figures, calculate unknown side lengths by using a scale factor. And number two, I will be able to connect similarity and dilations within the context of a problem. Okay, let's get started. We're going to refer to the picture at right to answer these questions. The first question is, what side of A prime, B prime, C prime corresponds to side CB? All right, let me see. Well, here's CB. And I can see that that corresponds to this parallel side right here. So that corresponds to side C prime, B prime. And which side corresponds to AB? Okay, here's AB. I'll use a different color. I can see that corresponds to its longer version, A prime, B prime. And the relationship between these corresponding sides is that they are parallel. You may also have noticed that one is double the length of the other. The prime sides double the length of the non-prime sides. Okay, how come A prime B prime lies directly on AB and A prime C prime lies directly on AC, but B prime C prime does not lie directly on BC? Let's think about that. Well, notice that the point of dilation is right here, right? Since point A is the point of dilation, since A is the point of dilation, the two of the sides which connect to point A overlap with the shapes. Now, side BC does not connect to point A, so it does not overlap. And this would be true for any scale factor which was solid and positive. Number 2, D. Could we determine the side lengths of A prime, B prime, C prime by adding the same amount to each side of triangle ABC? Okay, well, let's try that and see what happens. So notice that AC started out as 3 and ended up as 6. So AC went from 3 to 6. If I added 3 to BC, that would be 4 plus 3, which is 7. But that wouldn't be long enough because actually B prime, C prime is 8. What they're trying to get you to notice here is that the relationship between side length is multiplicative. I can't add in order to find out what a new side length will be. I will also always have to multiply by some scale factor. So you cannot determine side lengths by adding the same amount to each side. I know because the relationship between the lengths of the sides for the original and dilated triangles is multiplicative. Not additive. If you want a rule that will work for every side, it has to be one that has multiplication. Okay, let's continue. Now, Monica dilated triangle ABC to get a different triangle. Now, she knows that B prime C prime is 20 units long. How many times longer than AB is A prime B prime? See, to me, this problem needs a drawing. So she's saying she's dilating this original triangle again. And the original triangle had the dimensions of being a 3 across and 4 high. 3 and 4. 3 and 4. And she's saying her new triangle will be what? This part's a question mark. And this part is 20. Well, if this one is 20 and this one is 4, I notice that 4 times 5 equals 20. So 5 is my scale factor. Therefore, to find the new A prime C prime, and let me label these vertices. So we have to figure out the scale factor, and to go from BC to B prime C prime, B double prime C double prime, I know that I have to multiply by 5 because 4 times 5 equals 20. So that tells me that B double prime C double prime is 5 times longer than BC because 4 times 5 is 20. And similarly, A prime prime C prime prime must also be 5 times longer than AC. So that would be 3 times 5 equals 15 units long. This distance right here must be 15. All right, we continue. 258. Casey decided to dilate her favorite letter, the C, of course. She dilated several C's using a copying machine. The scale factor, or zoom, tells the copier how much to dilate the figures or text on the paper. For example, if Casey sets the zoom on a copy machine to 200%, that is the same as a scale factor of 2. So 200% would be a scale factor of 2. The side lengths of the C would be doubled. If she set the zoom to 50%, that would be a scale factor of 0.5. The machine would be shrinking the sides in half. Zoom is often written as a percent. Scale factor is written as a decimal or fraction. Now, the copier does not change any of the angle measures, and since the angle measures are preserved, and the only thing that changes is the scale factor, these are dilations. Casey wants to learn more about her dilated C's. And let's help her do that. Okay, part A. Since the scale factor multiplies each side of the original polygon, the ratio of the widths must equal the ratio of the heights. We're using the word ratio here. We'll see that's a word for fraction. Casey decided to show these ratios in the diagram at right. Verify that her ratios are in fact equal. Now, is 24 over 8 equal to 18 over 6? Well, both equal 3, so yes. 24 divided by 8 is 3. 18 over 6 is 3. Yes, they are equal. Yes, both ratios equal 3. Final answer. Okay, now vocabulary word. A proportion is an equation with two equivalent ratios. After looking at Casey's work, her brother wrote the proportion 8 over 6 equals 24 over 18. Are his ratios in fact equal? Let's think. Okay, I just use a calculator. 8 over 6 equals 1.3 repeating, and 24 over 18 equals 1.3 repeating. Yes, they equal the same thing. 8 over 6 equals 24 over 18. Okay, they're equal. Great. Casey decided to create an enlarged C for the door of her bedroom. To fit, it needs to be 72 centimeters wide. If x is the height of the C, write and solve an equation to determine how tall the C on Casey's door has to be. So we're just going to set up our equation and then solve it. We know that 8 over 6 should be equal to x over 72. And that's all it takes for our equation. Now we cross multiply and divide. So to cross multiply, I do 8 times 72 equals 6 times x, which gets me 576 equals 6x. I divide both sides by 6, and I get that x equals 96. Her new C is 96 centimeters tall. Okay, now Casey wants to reduce the C to wear on a little necklace. She has decided that she would like the height of the C to be 2 centimeters. What scale factor should she use to create her reduced C from the original figure? helps me to have this original figure. Okay, now scale factor, ding, 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 you should have that ringing in your head. This is image over original equals K. For us, we'll have K is the image 2 over the original 8. So her scale factor should be K equals 0.25. All right, what would happen if the scale factor between the two of KCCs was equal to 1? Well, let's solve for it. If I started with 8 and I knew my scale factor was 1, then I would have x over 8 equals 1. X would equal 8, but that would mean x didn't change. So if the scale factor were equal to 1, then we would have two congruent shapes because both the side lengths and the angles would be congruent. The original and image would be congruent if the scale factor equaled 1. Okay, let's continue. Okay, we have 2-59. Rashida drew triangle ABC at right and then dilated it through point A to create triangle A prime, B prime, C prime. All of the side lengths are in centimeters. And let's write our similarity statement. So we have triangle ABC is similar to triangle, the larger triangle right here is similar to the smaller triangle right here. So triangle ABC is similar to triangle A, B prime, C prime. And we know those are similar because dilations produce similar figures. Okay, Rashida then decided to redraw the diagram as two separate triangles, as shown below. Let's write a proportion and solve for x using the corresponding sides. Okay. I can see that AC prime corresponds to AC, x plus 9, and that should be equal to the proportion created from the other side lengths. I can see that AB prime 4 corresponds to AB, which is 10. Now I have to solve my proportion, so I'm going to cross multiply. 4 times x plus 9 equals 10x. Now I'll continue. I start with distribution. I have 4x plus 36 equals 10x. I want to get my variables all on the same side of my equation. I have 36 equals 6x. Now I'll divide both sides by 6 to get x alone, which gets me x is equal to 6. Okay, let's write another proportion using different corresponding parts and solve. Will we get the same value for x? I mean, first of all, what is this even asking? Different corresponding parts? I thought that we were only talking about side length as corresponding parts. No, there is an easier way. Okay, so let's look at the original drawing up here. 4 corresponds to x. Does it? It does. We can go across. So I'm going to do 4 over x equals 6 over 9. That gets me 4 times 9 equals 6 times x. I cross multiplied. Okay, that gets me 36 equals 6x. I divide both sides by 6, and I get that x is 6. Same answer. This is referred to as the triangle side splitter theorem. Okay, let's take a look at these next questions. How long is side AC? Well, side AC is x plus 9, which is 6 plus 9, and that's 15. How long is side AC prime? Well, that's just x, so that's 6. I promise we're going something with this. We're getting all of the pieces together, and then we're going to write an equation. What is the ratio of the original segment BC to its image B prime C prime? Okay, so that would be BC, which is an unknown length, BC over B prime C prime, is, might be a little bit confusing, but we actually do still know that ratio because all of the corresponding side lengths should be proportional. So it'll be the same as AC over AC prime. This should just be, no, that's right. Okay. So it should be the same as 15 over 6, which is 2.5. It should be the same as that. And I know because the triangles are similar. So corresponding sides are proportional. And this question is really trying to get us to do two things. It would probably be easier for us to do this numerically if we just pointed and used the diagram. But we're trying to connect the words that you read to the concepts that we're developing. Okay, part F. What is the relationship between B prime C prime and BC in the original diagram? So they have to be parallel. They're dilations, so they have to be parallel. They are dilations. So they are parallel. B prime C prime is parallel to BC. And they are related by the same scale factor as the other side pairs. Okay, let's continue. Let's write a little summary of the day. If two polygons are similar, then there is a sequence of rigid transformations. Followed by a dilation that maps one polygon onto the other. The converse is also true. If there is a series of rigid transformations and a dilation that maps one polygon onto the other, then the polygons are similar. Similar polygons have proportional corresponding side lengths, meaning they are related by the same scale factor, and they have congruent corresponding angles. The ratio of any pair of corresponding sides in similar figures is called the ratio of similarity or the scale factor. Let's take a look at this example. A sequence of transformations that could map ABC onto A prime, B prime, C prime is a reflection across a vertical line and a translation of C to C prime. Then a dilation by a scale factor of 2.5 from point C prime. To represent the fact that the two shapes are similar, we use this symbol, little tilde. All right, here's our original shape. And here is our image. And we're going to find the scale factor, but I'm going to refresh this page because I think it looks a mess. 1 second. That's better. All right, so we've got our original here. And our image. The scale factor is always the image over the original, so I'll do 5/4. And we have A prime, B prime divided by AB is equal to B prime, C prime. You'll divide that by BC. And A prime, A prime, C prime over AC. And you get 2.5 because 5 divided by 4 is 2.5. Nope, I made a mistake. This should have been 10/4. Sorry. Because 10 divided by 4, this length should be divided by this length, is the same as 5/2, is the same as 12.5 divided by 5. Okay, that's the end of the notes. I hope you found these useful. Thanks for sticking around. See you next time.